On this week's episode of AI Podcast in 26 minutes, we invited my good friend Kripa Rajshekhar. He is the startup founder of Metonymize. He's one of the leading machine learning experts in the world, and he practices what's called third wave AI, a term that was made by DARPA. Also conducted a recent study with MIT, Oxford, and others. He specializes in simulations, decoding human behavior. He knows unstructured text inside and out. He has some really interesting opinions on human in the loop. Kripa is obsessed with learning, participates in Chicago's tech scene, married his college sweetheart, has 2 daughters, and loves the motorcycle, read, hike, and meditation. Welcome, Kripa.
Welcome, Kripa.
Hey, thanks, guys. Thanks for having me. This is great. I've been listening to your stuff, and very very happy to be.
Yes, we have another listener.
One more.
That makes it 4.
No, definitely
including us.
6, definitely 6.
6. All right, that's right.
Right.
You pay someone to listen to.
I want to open with giving the both of you a little bit of a hard time. For folks who are working with data and are working with probabilities and predictive, why are you riding motorcycles?
they, a lot of the sort of crashes happen when people lose focus and don't pay attention. And when you're on a bike, you're always paying attention. It comes with the territory. So,
well, the average commute is 26.1 minutes, and now that I live in LA more than Chicago, I have to ride a motorcycle to get anywhere in 26.1 minutes because the traffic is horrible.
You're both dodging the math on it. I mean, everybody's who rides a motorcycle, the chances of accidents, I mean, it's publicly available data.
Well, to be fair, my usual bike ride is all of a mile and a half, which is from my home to the Whole Foods or from my home to the train station. So I might be dodging the bullet by just not ever going over the sort of critical mileage level.
All right. So this sounds like a data science project out there for somebody who's auditioning.
Well, the thing about Kripa is I've listened to you talk a bunch of times. I love listening to you talk, but you always bring up things like simulations and augmented AI versus artificial intelligence and things like that. So you approach problems a little differently, and I think that's why you're brilliant.
Nerdy.
What is your approach?
We love nerds. I do a nerd happy hour every month.
Besides cycling to the train station, from I guess in Deerfield, I assume, and or Whole Foods, where I presume you sit there and have your coffee and work there. What else is different about your approach, and what is third wave AI?
Yeah, no, I've talked to your head off multiple times. I know, Brian. There's sort of 3 waves. The third meaning there's like 1 and 2 that happened before, and it's actually something that DARPA coined. It's the third wave of AI, the way they see the world, and I think it's very helpful. At least it was very helpful for me to kind of get situated and framed. First wave was kind of people just programming using expert knowledge. And then you could give these people tons of data and they would still have to do what they were doing before. Nothing would change. In the second wave, you really didn't need people that had to code in great detail. You could sort of instead use very powerful computers and vast amounts of data and then just induce sort of quote unquote programs, which were essentially these deep neural networks or other kind of machine learning models that got stuff done. And third wave, you could think of it as a synthesis of these waves that came before. And it's much more about, how do you learn to do context adaptation, to kind of respond to stuff which you haven't seen in the data before. Your audience probably, and you guys probably know of one-shot learning, kind of small sample learning, unsupervised learning. These are all kind of part of this third wave movement.
Is human in the loop part of that, Kripa?
Yeah, for us, so our take. Now, this is kind of a more general answer I gave you, but from Metonymize, from my perspective, from our team's perspective, we see sort of experts as being the sort of kings of the first wave, data scientists as being the kings of the second wave, and users, consumers, people, as being sort of able to come in on the game in the third wave. And the way that works is human in loop, right? So if I can sort of provide a few examples, the machine can propose a program. I can provide a little bit of feedback that adapts that program very quickly. And then that program can be handed over to the experts or the data scientists so that they can manipulate it further. You essentially open up the entire programming game to everyone, right? And for me, that's the most inspiring part about this third wave, which is, very, very human in loop writ large is very central to that concept. If
Wait,
that makes
wait a
any
minute
sense.
now. Now, deep learning and neural networks you put in the second wave, and those are pretty new technologies. Are you saying we're already on to another chapter?
Yeah, I mean, they're obviously very old technologies, right? Like as we know, I mean, neural networks as the architecture and framework are many decades old now.
Mm.
So the breakthrough, of course, was that you had a lot more computing power, and
Right.
then you had the exploding amount of data that could then be used to train these architectures using these computers. So as a technology, it's a very kind of traditional way of doing essentially function learning, right? Functional approximation. So if you want to learn a relationship between X and Y and a statistical relationship, neural networks have been a good way to do that.
Mhm.
Um, but I think what we've been missing is a way to have human expertise, data, and compute all kind of coexist in a unified representation, which allows things to get better depending on what you have, right? So that you're not. I think where neural networks are right now is if you want to use like vast amounts of compute and you don't have vast amounts of data, you're sort of out of luck in the neural network business, and that's unfortunate, right? What you
And
like is
the problems you solve too, they're sometimes involving different types of data too. Like you mentioned unstructured data quite a bit, and I know you've done a lot of natural language
Mhm.
processing.
Yep. Mhm.
Can you speak to the landscape of data that you're dealing with, and also a little bit about you've been pretty hard on big data too?
Yeah. I mean, I, I've got nothing against big data. I think um, data is one of the inputs that I think we can use to create more models of more complex behavior. But I think it's just one of the inputs. And if you take an example of you talked about language, and there's been a lot of hoo-ha about OpenAI's GP2 model that was only recently kind of released in its full glorious form. And if you go on the website and try and play with it, the most simple kind of sentence completion tasks, it just flubs, right? And it's an amazing model. It's very, very powerful, but it lacks context. And I do think we kind of, all of us maybe have kind of overstepped like where AI is and where it can be by just scoping the problem in a way which is really hard to do well, right? Sentence completion, which doesn't sound like a very complicated task, is a really tough and ill-posed task for a machine to kind of solve well. And I'm much more interested in natural language problems where there's very regular feedback and interaction. So some of the work we're doing right now is in the area of really understanding intent and understanding kind of how to feedback on that intent. Let's say in the context of shopping or in the context of analysis, and then have the machine and the human go back and forth more frequently, almost kind of chatbot like, but in a way to kind of goal oriented and together solve a problem which is very, very different structurally than giving a whole bunch of training data and having it kind of work all at once. I don't know if that answer made any sense, but that's kind of where we're thinking.
Let's go back to the autocomplete because I think that's particularly a favorite of Brian's. For example, he cites a statistic of how much time autocomplete and Gmail saves. And I think people see it and they kind of just take it for granted. Why don't you just walk us through how complicated that is? Because, of course, Google has some of the best people practicing AI and they can afford the computing power, right?
Yeah, yeah. And it all comes back to context, right? So one of the sort of, like, just to poke fun a little bit, what I tried to type in was, the square root of -1 is blank, right? And I ran that through the algorithm, and the answer it returned was 0.5.
Or
Right.
42. I'm surprised it didn't say 42. Yeah.
That would be a Twitter with a good sense of humor, right?
Well, that's really what a lot of the chatbot stuff ended up becoming, right? Which is ways to dodge questions, ways to sort of, we anthropomorphize stuff so much
Mm-hmm.
that you could take any answer and kind of, there's this word, right, post diction, which is after the fact you could come up with a story that makes that completely sensible or explains it, rationalizes it. And I think that's uh, that's a I feel like we might have quite a bit of problems in the future if these problems become harder to detect, right? Where the answer, if I didn't have some basic knowledge of mathematics, and you said, what's the square root of -1? And it said half, like, if I didn't know of the concept of imaginary numbers, and I wasn't sort of really paying attention, it would seem like it's giving me an answer which is a number. And, hey, like, if I'm not thinking too hard, do I really know whether this thing has made a mistake or not? And what are the implications when you extend it to all kinds of other problems, right? In all of this kind of Twitterverse stuff, which
Yeah,
people are doing.
absolutely. So, I mean, basically, what you're saying is that where you might be deprecating the intelligence of man
Mm.
when machine learning is being misused, or if we don't keep expertise in the loop, if you will. Speak more about that because that's an interesting topic. What's the precautionary tale here about AI?
Well, I think if you go back to Licklider and some of the people that were at the very birth of the internet, and the very first wave of computing or AI or whatever you want to call it, I mean, those people were all about augmentation. They were all about sort of man-machine symbiosis. Sort of, these are the sort of concepts that were inspiring them. And I think we'd be well served to kind of go back to those roots in this third wave and to say, how do you kind of solve this problem in a, by definition, collaborative mode, where architecturally, and this is kind of what a lot of what we're doing with our company is, you just start with that goal, right? So you have the machine, you presume humans right next to the machine, and then you just throw a goal oriented kind of problem at this combination of resources, which is human plus machine. And you then give them facilities to communicate with each other to get the job done. And this is very much their vision. So if you read any of Licklider's early papers from 62, 64, he talks about amalgamation. He talks about human capabilities, computer capabilities. He talks about online inventiveness. And I just think I find that stuff super impressive and super inspiring. For us, even we don't have to automate everything. Like, I think it's much better to figure out ways to solve more challenging problems, but with this fabric, like a hybrid fabric, which has people, machines, all kind of interspersed. I just don't see enough of that stuff going on out there. And at least when I talk to friends, it it feels like we're focusing on quote unquote solving intelligence, which I just, that's a fine as a science fiction project, but like there's so much other stuff that we can do before we get to solving intelligence. Like, we have to understand it first, right? And I don't know if that answers your question, Brian. I know you and I have talked about this a little bit, but how do you think about it actually?
I always say this in the podcast too: is the man versus machine, machine versus machine. I like to see it as man and machine,
Right,
so that there's some sort of symbiotic relationship between the two.
right.
I mean, and I think you see that too. And I've witnessed firsthand some of your demonstrations of technology where I've never seen a better representation of human in the loop, where you can do live retraining of models
Mm-hmm,
and
mm-hmm,
interface with things. I mean, that's the future. But
mm,
here's a question for you: is how easily is that idea conveyed to people, to other people who may not even be data scientists? How do you take your very technical ideas, and I've even read your patents that sometimes beat Word to Vec and other things.
mm-hmm,
How do you take these very technical things in Kripa's brain and squeeze them out onto the conference room table? Kind of a gross analogy there,
mm-hmm.
but how do we get those, and how do you make them so easily consumed by the business?
Yeah, I mean, I think we have to focus on the problem that we're attempting to solve, right? And which is really where it all starts. And for us, what we're saying is, we're very focused on the problem of relevance now, right? So relevance is a really important concept. So we know when we're looking for something, what we're looking for, and we have a representation in our minds of what the ideal goal or outcome is. So let's say I'm shopping for something on a website. I know what I want, and then the interfaces that we're provided today force us to sort of turn that into a search query or something which is much simpler than the representation we have in our minds. And I think what we're trying to do is we're trying to say that in the world out there, when we go and have an exchange with a vendor or a librarian, we're having a conversation, and through that conversation, our question actually evolves and changes a lot more than many of us account for in advance, right? And I think it's that process that we're trying to capture. And you've seen this, Brian, in some of the demos I've done at points before. It's really an interactive process where I start off with some data. I start off with a question. I get some results back, and then I modify my query and I modify my representation. And it's a process of actually changing the question as much as it is a process of getting a different answer. And I think that's the conversation aspect, the relevance aspect. Those are some of the kind of deliverables that we try and understand more with our clients. And I know in the legal field, very early in our development, it was a huge deal because language in law is very structured, and you just can't put it through a word to vec kind of algorithm and get what you want. And we're seeing the same today in the area of, call it, shopper marketing. Or relevance is you just can't solve it in one shot. You need multiple people. You need multiple passes at the problem. And that's kind of what we've been working on.
When you're speaking to your customers to investigate and discover what the real problem is, are there particular questions you ask every time of every customer?
Usually it's relevance, right? So it's basically, if you're a shopper marketing person, or you're a brand, my question is usually, you have a whole bunch of knowledge within your team. How are you using that to sort of more quickly get to relevance, right? So if you're running a new campaign, let's say on Amazon, all the keywords that you want to sort of flag um, ultimately need to sort of connect in a mirror image with shoppers on the other side. Those starting points need to be informed by your opinions on what makes you relevant to your shoppers. How do you translate that? Like, how do you take this knowledge, which is extremely, like 500 slide pages, whatever, like all this material, which is in all kinds of weird formats? How do you take that and turn it into a representation which drives relevance. And as a starting point, you just can't solve it in one shot. You put a hypothesis out there, shoppers react to it, you learn from it, you modify it, and it just keeps getting better and better over time. But it feels like it has to start with, what are your priors? Like, what sort of knowledge do you have? And are we letting the technology bully us into saying that if your knowledge is not in form of like a training data file, we can't use it, right? And I think that's the problem which we end up seeing many of our clients just giving up on, because they're forced to say, collect structured a particular type of data, and then the machine learning algorithm works. But if you have other forms of knowledge, well, get a programmer, right? Or something like that. And I think that's the type of conversation starter I've used a fair bit. But our use case is very, very particular. So I don't know if it kind of translates to all problems as such.
Mm-hmm. Curious if you have an estimate on how many models that are developed in business orgs actually make it to production.
That's a great question. It would be, I don't know, like, it feels like single-digit % at best, right?
I think I'd agree with you. I think that might be surprising for some of our
That's a great question.
Listeners.
And, it's sometimes the goal, if you think scientifically, is to prove that something is needed too. If it doesn't work, that's a good answer sometimes. And I hate it when, I don't know if you've ran into this yourself, Kripa, but researchers or different areas, they'll spin their tires too much. They'll try to force a problem, or they'll try to, if you're not getting the data, you're not getting the results you want. Sometimes it's okay to give up and move on to a better part of the problem, right?
Yeah. Yeah. I mean, I think it was Polya, or, the How to Solve It book, again, from that sort of golden age, like I think it was like the 50s, 60s, some of that period. I might be mistaken, but his book was just fantastic in this area, where it's like, the most important part is like asking the right questions, right? And so sometimes you got to just change the question you're asking, and it becomes easier to solve. And it's really hard. Like, the machines are excellent at giving some answer to the question you pose, but I think we need a lot more help in coming up with many, many better questions. And I do think sort of this next wave of AI is going to sort of be a lot more productive in that human in loop, Brian, that you kind of referred to earlier, especially in the area of question formation and exploration, interactive exploration. I think those are like really exciting areas that I'd love to see where all of this goes. Very exciting times, I think.
Sounds like you have a lot of books in your home. Does that cause marital strife?
That's where the meditation helps.
Yeah.
Well, you met your wife in college, so I think she must have known that you were a bookworm at the time, I presume.
Yeah. There's she's an engineer, and one of the early gifts I gave her was like this book on civil engineering, and it was the last time I gave her a book as a present.
That's like giving someone a vacuum cleaner. Here, this causes work.
Right.
No, I think it's important.
Great idea.
It's important about bringing up the reading, since I think for some of our audience that we're trying to reach don't understand that there's a lot of reading that happens before you start deploying any code or any AI.
Yeah, actually an engineer that a boss of mine in the past said, before you start working on a problem, turn off your monitor. This is back before laptops. It ages me a little bit, but turn off your monitor. And I thought that was an interesting thing, is, how well are we doing at thinking about the problem, and sometimes we not so well, but, we go hands on keyboard really quickly. What is your thoughts of like these roles coming out, like the citizen data scientist and stuff like that? Are we bypassing thinking with some of this, or is this conducive? Is it helpful?
Yeah, I'm not sort of as close to it as I probably should be. So I don't know the particular details, but I love what both of you just said, right? That and I think it's called like hammock based, what is it, hammock thinking or hammock style of coding, where like, and that's the scientific method too, where you formulate a hypothesis, which is really a story. You say, hey, this is kind of how I think things are. And then you ideally want the computer to very easily take that concept you have in your mind and allow you to simulate it and just, let the data beat up on it. And you'll find that your story can change. And that, I think, my hope, Brian, is that uh, with programming by few examples, with some of the stuff which even we're doing, I'd really love to see, in a couple of years, ways for many more of us to just engage in this process of creating new simulators, creating new models of the world, without feeling like we have to learn coding. And I don't think we're that far off.
I want to keep this within our 26.1 minutes. And what's a takeaway, Kripa? What do you want the audience to walk away knowing? What are you going to work on next, or what's a final sentiment?
It would be in this area of, are we just thinking about the question wrong? And instead of saying, whether we should solve intelligence, or even thinking about whether there's one centralized way of building intelligence, I mean, what if we were to flip the question and say, hey, is it possible to actually not be able to build intelligence in any other way, right? That you absolutely need a society or a community to actually come up with intelligence together, just like language. And I think that would be an interesting conversation to have. And it's certainly one that I'm very interested in, pursuing with the work we're doing. But I think it's a great conversation, and I just don't think it's being had right now. So yeah, I'd love to leave you guys with that.